Well, I've managed to pull it off, as in do the Spinneytronic Harvard H646. So it says Spinneytronic on the back because it was. They were made for Littlewoods Catalogue Group, and it uses the fake version of the Cybernet 002F chassis used in the Cybernet. Start again, used in the Amstrad. So it's not the Amstrad chassis, it's the Cybernet 002F chassis, which is used in the Amstrad. But as I've said a million times, there's a £59.99 version. There's the original made in Japan £89.99 version. There's the Amstrad 900, which is always the genuine version, £79.99. And then you get the fake Hong Kong version, which was £29.99. Well, this uses that £29.99 chassis, and it appeared as a Spinneytronic CB199 for Littlewoods Catalogue Group. Now, all their returns were sold to Harris Overseas Limited, who do the Harvard brand. So they've overstamped them with Harvard. But the good thing here is that these were all reworked in the UK. So all the returns to the Littlewoods Catalogue Group got returned and got turned into Harvard H646s. So chances are that these work better than the Spinneytronic because they were re-engineered here in the UK. So Harvard H646, it has come with the original mic, and I will show that later on in the video. I'm going to do it on our mic. The customers, it would originally have been the square round socket as it would have had, and he's refitted a new connector there, which is fantastic. So what's the date today? Oh, I wouldn't be surprised if it isn't the 23rd of January. So it's Harvard H646. $805,784. These are about 1983. I'm going to try it as it is. Would have helped if I'd have brought an Amstrad square round lead with me, because we do make those and offer them on eBay. And hopefully it's the right way around for our crocodile clips. Yeah, it is. So we'll go to 13.8 volts and put in our mic and switch on. Now the squelch on these is always iffy. A lot of these sets don't hiss at minimum squelch, but as soon as you put the aerial in, they do. That isn't a fault, it's the way the design is, because it's not a perfect copy and it doesn't use the same components, and you'll all appreciate there's such things as component tolerance, especially when you use cheaper parts. Amazingly, these I think usually use the Tango coils rather than Billy No Mate's coils in the real Cybernet chassis. So some parts are actually higher quality. Switch that off, switch PA on, testing 1 2, testing 1 2, testing 1 2. So PA works, that's a jolly good start. So put it on channel 20. Seeing as 19 is useless and full of Burner Brigade bucket mouth wallies. And we know that the internal speaker works, and we know the PA function works, and we know both the sockets work, so it ticks off switches. No, I'll come to that. You're not telling me I haven't woken up at 9:30 in the morning. So I put the squelch to minimum, RF gain to full, and we'll go into picture in picture and let's see what power it's doing. Might help if we plug the test equipment in. Right, keyed up. Oh, good. 3.5 watts on channel 20. So it's already above 3.4, so we won't be doing the ballast resistor because it's already there. So it's 3.5 watts. As I said, if we get more than 3.4 watts, I don't need to do the ballast resistor. If we're getting under there, then you know it does need to be a little bit more. So let's have a look at channel 40. 3.4 watts, and on channel 1 3.4 watts. Low power. Oh, they are a faff, aren't they, these little switches? Low power. Oh, it's 410 milliwatts. It's really good. Tell you what, the genuine ones are never as close as that, but it won't be by the time we've retuned the transmitter. And the current consumption is actually very good at 1.041. Deviation, for what it's worth on this test set, 1, 2. It helps if we go to channel 40, doesn't it? Channel 20. Wallow is 2.8, which is not far out where it should be. VCO will come to. Test set's been on 10 minutes, so what it reads here we'll take with a pinch of salt. Frequency is camera 2. $27,791,000. And I've always said, as long as we get them over 791,000, if we can't get them to 27,791,255, that's fair enough. It's near enough. It's well within tolerance, and it's so trying to get a crystal that works better is not easy. So with that, we'll put that into the signal generator, 27,791,000. So we're testing this receiver on the same frequencies the thing's working on. It would be very naughty to test the receiver on spot on frequency when we know the thing's very slightly out. That will do me. So put the SINAD meter on, and sounds a bit strangled. Let's go over to camera 4, the one that gets moved by the mice. Caught a mouse in the mouse trap in the back workshop where Mr. Chippie normally has his things. Threw it out, and you know, by the time you get up in the morning, anything like a dead mouse you throw out has been eaten by something else. So, what's it? I mean, what have we got on sensitivity? We've got 0.24. But of course, if the detector's out, this will be false. 0.21. 20. Ooh. We can't get 20. And we may not be able to because of the quality of the components. Now, the squelch is the biggest letdown always on this chassis, even on the genuine version. It uses the mute circuit built into the LA1230 Sanyo IF system chip, which was designed by Sanyo for hi-fi stereo tuners. You know, when you're tuning between stations, some hi-fi tuners have mute, which of course is squelch, and they utilise that as the squelch in this chassis. You see, on a lot of sets they use the Motorola MC3357, and that has built-in squelch, but that's designed as a two-way radio FM chip, whereas the FM chip used in this is designed for hi-fi systems. That's the difference. And the only problem is the squelch is a letdown. So we'll drop that to signal generator off, set threshold, see where it comes in. It's put the attenuator up on camera 6 and switch the signal generator back on, straight in at 0.3. So sensitivity's there, but what's full squelch like? Turn it to full and it is 4.5 microvolts maximum, and this can be the problem. That isn't it. You can work this in conjunction, of course, with the RF gain. Right, let's look at the meters. So on receive we've got 7 showing, so what we need what for S9? It's there, isn't it? It's not far out, it's 210 microvolts. There's no hard and fast rule on this, but I like it to be 100 microvolts. There is a hard and fast rule on this. It's the squelch isn't hard and fast rule. It's 100 microvolts for S9 on a CB radio in the UK. For a ham radio, I think it's 54 microvolts. It doesn't have one of those. But we're not dealing with ham radio, and we don't deal with ham radio. And anything I've got which is ham radio has been converted from a business radio or has been built by me from scratch and doesn't have an S meter. So don't ask me how many pounds I'm pushing you on ham radio, because I wouldn't know. Right, we're done, aren't we? Oh, on transmit, let's see how many lights it lights. It shows 4, which is what you'd expect, but it isn't doing 4 watts. Right, we'll open it up and make a start, and we're going to start with the VCO. I could sell this pen, couldn't I, in some art thing. It's got a splodge of solder, which is just really artistic. This has come from one of our regular trade customers. He'll have done a lot of the basic things himself, which he can, and he'll just the sensitors for alignment. And then we'll go back to that previous customer who the last Amstrad 901 was from, and the York 863 and that Jason KR200. So we've got soldered on speaker wires, and we'll do the customer's Banatone 5-star, then he can have his sets back. So here's the big thing, apart from the fact that it smells of nicotine. You'll notice the printed circuit board doesn't have the screen printing, so I'm not sure I've got an Amstrad to show you, because I haven't. Most of my scrap ones are this version. You know what? I think we've got a sacrilegious. This is a. We bought this as a scrap chassis. It's a Mustang 3000, which has been sprayed gold with its works off as somebody's art project. I mean, to smash up a set like that. Well, this uses the genuine Cybernet 002F chassis. So you put them side by side. Of course, they're the same. But here's the big thing. When you open this up, you'll see all the component locations are screen printed. When you open this up, there is no screen printing. So if you get the Amstrad, which is made in Hong Kong and does have the screen printing, then that is the cheaper but what I believe to be genuine one. If you get the Hong Kong one without the screen printing, then it's the fake one. Or it's the Harvard H646 or the Spinneytronic or anything else that uses the fake board. So there you go. And there's a big difference in the build quality of this £90 set and that £30 set. Although these sold for £90 because the catalogue company made a big profit. Right, we should be warm enough to unsolder the speaker. I think they usually are on tags. I think it's just lost its tags over the years. At the end of the day, it's 40 years old, isn't it, like the rest of them? So it's got a better ballast resistor than you actually got on the Amstrads, which is probably why it's doing a bit nearer the power. So I'm going to drop it to channel 1. We'll do the VCO. I'm going to try and get the transmitter done before taking a break. I can only do CBs for, you know, like 40 minutes a day. Right, let's get this done. There's every chance of being able to complete this one today because I just think it's going to be a retune and test. And then we can get that out and it'll be just like being able to, having done the Amstrad 901 last time, it'll be jolly good fun, won't it? Because we can compare them one after the other. Where are we going to connect this to? One of those coils probably. Right, so far side of that capacitor is supposed to be about there, and on transmit it's supposed to be about there, so that's fine. And on transmit on channel 40 it's about there. It's absolutely fine, we don't need to touch the VCO. And I've shown you this with the service manual umpteen times. So it is important to check the VCO on this chassis. You can actually end up with minus voltages. Right, so go into transmit, see if we can tune it up. So you can see these are all Tango branded coils, whereas the genuine version, it's got, well, they're Marvel branded, aren't they? But I think they're Marvel branded. See if I can get that back. Oh, there's another genuine. That was once a genuine Amstrad. But as you can see, we've bought the chassis and it's been smashed up. So let's see if I can see what brand these coils are. I mean, it doesn't mean that they're crap. It just means, yeah, they're Marvel. I mean, I don't know who they are. I'm not Japanese. They may be a fantastic company of OEM coils, but at least Tango is a brand that we can recognise, even though they've now gone. Right. So in the high power scale with 3.5 watts, better go to channel 20. And we're going to tune for the centre of the peak. That's broken. So these use a different tool to the genuine one. Does the blue one fit? Yeah. Can we get this out? I've got this really deeply in the hope I can get it out. So I've just moved away the broken bit and we'll put it in the other way around. See, the broken bit acts as a wedge, so it can be difficult to shift. So we'll just do a final check. We're at 3.8. Just make sure these coils haven't been messed with. Placement's critical. That one's been factory messed with, I think. Yeah, 3.8 with it being hot, that will be 4 when it's cold. I'm going to jot 3.9 down. See where we are on channel 40. I like it to be within 0.1. 3.9, channel 1, 3.9. I've got that nicely balanced. Now this will have sent low power haywire. Get rid of that, which is non-adjustable. So where is it now? Low power range. It's now 450 milliwatts. So back in the day, theoretically that would no longer be legal, would it? Because it would be beyond the 400 milliwatts you were allowed on low power. Which, if you remember, was when your base station area was mounted more than 7 metres from local ground level. I wonder how many people flicked the switch. Right, we're not going to do deviation yet. Let's have a look at what the current consumption is. Are we back in full power? No, we're not. And our current consumption now 1.204. 1.204 amps. So gone up half a watt. We've done the VCO. It's 2 plus 2. It was 2 plus 2 before. Absolutely fine. We'll do the meter, which should read 4. Let's see whether it still does read 4. It's touching on the 5. I don't want to do that, so we'll just drop that down. That's the preset. There we go. On low power it should be 1. It is. Back to full power. We'll do the deviation on the other test set in a moment. What else have I forgotten? Oh, let's see if we can get it on frequency a bit closer. It doesn't matter if we can't, it's near enough. But always try. So let's have a look what we've now got. 2779103. I'm going to leave it at 2779124 because the test gear will go up a little bit more. 2779125, and it will be. Right, deviation. So I'll tell you what, I mean, this works really nicely. Ugh. See whether this is warmed up sufficient. Wow, it's not far, it's a little bit low at 2. Wow, now it's 2.5 absolute peak. Plug it back into the Marconi test set and we'll see whether it's lying or telling the truth. So the deviation meter section of this needs capacitors changing, but I'll be quite frank, I'm not well enough to do it. Wallow. Which mode are we? That wallow. Yeah, it's lying today. Good. Well, that's done. We'll listen to it on this walkie-talkie and just check that the Roger bleep's working. Testing 1 2. It is. So the switches all work. I've already proved that. I'll check channel 9. We hadn't ticked off those potentiometers. We've still got to check. That is for and correct. That was 2.1 kilohertz. It's now 2.2 to 2.5. I've just got 5 minutes. We can make a start on the receiver, and here we go. So the first thing we're going to do is look at camera 3 on the oscilloscope and see if the detector's in the optimum position. So it's maximum recovered audio, just across the speaker, nothing clever. Miles out. It's funny, you know, yesterday's was as well. So the receive sensitivity will be adversely affected now. So I think we'll do the IF next, like we did yesterday. I just need to see the edge of the S meter as well. Right. Put the SINAD meter up. Camera 4. So we're doing the IFs. That's exactly where it should have been. It was. That's exactly correct. No, they're all spot on. Now, you know, isn't that funny that the detector's miles out, but the IFs are spot on? Okay, we'll do the front end now. See whether we can get a little bit more out of the receiver. Tiny fraction on that one. Let's go back to the first one. So they can't do this at the factory. They can't be going backwards and forwards. They'll just go to a line and that's it. So now we're going to get a reading, and it will be inferior to how we started, simply because the detector was so far out. But you never know, we might be able to get 20 dB on it now. So let's see where we are. Let's go to, we're on the SINAD meter. There's our 12. Yeah, it's now 0.36. Of course, with the detector as it was, it would have been garbled, which is alright if you're listening to Daleks. 10 dB, 0.32. And it now does 20 easily, 0.72. Right, let's see where we are with the S meter. 100 microvolts on a signal generator. We want it to light S9 but not plus 30. And when I increase the signal on a signal generator, we want it to be able to light plus 30, which it does. Excellent. So that just leaves the squelch. Haha. So that's iffy at the best of times. Can we get it to squelch out where I want it to be, which is 100 microvolts. That is maximum where it was. 4.5 maximum. Where was it before? 4.5. No change whatsoever. See where it is on the sensitivity. So set threshold on the radio with the signal generator on standby. Signal generator back on. Straight in at 0.3, exactly as it was before. So the only way you get better squelch range is to fiddle with the RF gain. Right, we just want the S meter. So 100 microvolts. Oh, I did that, didn't I? Yeah. I just didn't tick it off. So there you go. So you can see the chances are these are going to do nearer 4 watts without any changing of ballast resistors in the real article. That's closer than we get on the genuine Amstrads or the genuine Cybernet 002Fs. Usually you end up with 250 milliwatts. But then, from a legal point of view, that's over what would have been permitted. I feel there's more variation on frequency with this fake version than just on the real one. But we don't get quite the sensitivity, and we get this awful squelch action, which is very limited at 4.5 microvolts. They're always like this. Sometimes you can't get them to hiss unless there's an aerial plugged in. Right, there you go. So all I need to do is show you the factory original microphone, and we're all retuned, ready for an on-the-air test with Mr. Chippie. So I'll come back probably after lunch and finish it off. Okay, well, I left this open because I thought that we'd got the Harvard original mic, but I can't see one. He sent quite a few mics in. There's a binatone mic, and that's good because the binatone 5-star. There's a couple of power type mics, but I can't see the Harvard mic. I think it was probably the Eurosonic mic which is in his box. Yeah. Right, so we'll put this back together and do the on-the-air test. Just have a quick look underneath to make sure there's nothing nasty. Potential dry joint there. Potential dry joint there. I don't think this has had big hours. No, that'll do. There's no kind of burn marks where the output transistor is. Right, let's find the speaker lid. So often find the squelch action works worse than this one has done, so it's better than I was expecting. You've got sharp edges, which you don't get on the Cybernet Japanese one. Nearly. Right, get those tightened up, put the aerial on it. Right, we've got the aerial on it now. It's on its own speaker. One Nano, Roger.
To Bunkerville at Lincoln. Then I've got 10 to 20 gravel from Spinneytronic to...
There we have it, the Spinneytronic or Harvard H646, which is the alternative version of the fake chassis of the Amstrad 901. Thanks for watching.